Welcome, Standard 11th Commerce, Subject Mathematics and Statistics.
Lesson first, partition values. Interesting and easy lesson from paper second. First, you learn in this lesson meaning of partition values. Then partitions, first quartiles, second deciles, and third percentiles. Graphical location of partition values. Let us see one by one. First, meaning of partition values. When the observations are arranged in ascending or descending order of their magnitude, and further they are divided into n equal parts. Value for n will be 2, 3, 4 up to infinity. You can divide data in equal parts. Then observations which lie at partitioning positions are called partition values. We have already studied the concept of one of the partition values, namely median. Up to 10th standard, you have learned this concept of mean, median, and mode. Median is one of the tools that divides given observations in the two equal parts. So mention here. Median is a special type of partition values because it divides the data in two equal parts. The median, quartiles, deciles, and percentiles, etc., are termed as partition values since they divide the given data in equal parts. We are going to study three types of partitions in this year as quartiles, deciles, and percentiles. Let us see first one here, quartiles. Word quartiles. Simply data is divided into four equal parts. Let us see definition here. Quartiles divides the observations in four equal parts when arranged in ascending order of magnitude. There are three quartiles, that is partitions Q1, Q2 and Q3. Let us see diagrammatically given set of observations divided into four equal parts. Check this: first, second, third and fourth. Data divided into four equal parts. Then the partitioning positions, that is Q1, Q2 and Q3. These three values, they are called as a quartiles. Q1 you can say as a first quartile, Q2 second quartile, Q3 third quartile. Other names are Q1 for lower quartile, Q3 for upper quartile, and Q2, that is middle quartile. You can check here. For the partitioning value Q1, 25% observations are below this Q1. For Q2, totally 25 and 25, that is 50% observations are below Q2. And last, below Q3, number of observations will be 25 plus 25 plus 25. That becomes 75% observations are below Q3. Alternative way, you can write observations above partitions also. That is, above Q3 are 25%. Above Q2, 50% observations. Above Q1, 75% observation. Like this also. Let us see here one by one. Q1, that is first or lower quartile. 25% observations are below Q1 and 75% are above Q1. Next, Q2, is the second quartile, that is median. 50% observations lies below it and 50% observations above it. And last, Q3, that is third or upper quartile. For this quartile, 75% observations are below it and 25% observations are above. Simple here tool, quartile, given data divided into 4 equal parts, and their partitionings are Q1, Q2 and Q3. Let us see formula for quartiles for raw data. Raw data observations are given certainly, like x1, x2, x3 up to n observations will be provided to find out the values for quartiles. Method, check here, formula for quartile Qi, value of I times n plus 1 by 4th observation, where value for I is equal to 1, 2, 3. If you put I equal to 1, you will get first quartile Q1 formula, value of 1 times n plus 1 by 4th observation. Next, I equal to 2, that is Q2, second quartile, value of 2 times n plus 1 by 4th observation. Then last for I equal to 3, Q3, that is upper quartile, value of 3 times n plus 1 by 4th observation, where the small n indicates total number of observations. Exercise 1.1. Question first. Compute all the quartiles for the following series of observations. Given here series, check these observations. First step, for these given observations, arrange in ascending order. Children, you will first arrange these observations in ascending order. Let us see, I have arranged already these observations in ascending order. Counting total number of observations first. Check. Here 15 observations are given. N is equal to 15. To determine all the quartiles, that is Q1, Q2 and Q3, formula for first quartile Q1 is Q1 equal to value of 1 times n plus 1 by 4th observation. Substitute value for n is equal to 15. So Q1 is equal to value of 15 plus 1 by 4th observation. 15 plus 1 addition 16. 16 divided by 4th observation. Division 16 by 4, it is 4. So value of 4th observation. Check, already observations are arranged in ascending order, first, second, third, fourth. Fourth observation value is 9. Hence, value for first quartile Q1 is equal to 9. For next quartile Q2, Q2 is equal to formula, the value of 2 times n plus 1 by 4th observation. Again substitute n value, n is 15. So 2 times of 15 plus 1 divided by 4th observation. 15 plus 1, 16. 16 divided by 4, division is 4. And 4 multiplied to 8th observation. Check in counting. 8th observation is here 16. Hence, value for second quartile Q2 is equal to 16. And last, upper quartile Q3. Q3 is equal to value of 3 times n plus 1 by 4th observation. Substitute n is equal to 15. So 3 times 15 plus 1 upon 4. Addition 15 plus 1 16. 16 divided by 4. Division is 4. 4 into 3, that is 12. So value of 12th observation, check in this order here. 12th observation is here 27. Hence, value for quartile Q3 is equal to 27. So here we obtain all the values of quartiles Q1, Q2 and Q3. Hence conclusion, required values of quartiles are Q1 equal to 9, Q2 equal to 16 and Q3 equal to 27. So today lecture you have learned calculation for quartiles for raw data. In next lecture you will learn quartiles for group data and ungrouped data.